Okay, in this video we'll be solving radical equations. So a few things we got to remember. If you got a square root of a and you square it, it's like this cancels out the radical and you get the a. Same thing with a cube root. If you got a cube root of a variable, when you raise it to the third power, those sort of cancel out and you're left with the a. Same thing on the fourth. If you got a fourth root, you would raise it to the fourth power to cancel out the radical and get the a. Now in this section we'll also be using what we call the raising each side to a power principle, which says if two sides are equal, then I can raise each side to a power and they're still equal. Now, how to solve. First thing we'll do is get the radical term on one side by itself. Then I'll raise each side to an exponent that matches the index of the radical. So if it's a 2, I'll raise it to the second power. If it's a 3, I'll raise each side to the third power, and so on. Alright, once I've done that, radicals will be gone, so I'll solve for the variable. Once I solve for the variable, I will check my answers if needed. Now, if you do a situation where you got a square root of your x equal to a negative a, and this is either a 2 or a 4 or an even number, then that means you get no solutions. Because when you square them, you're going to lose that negative, and then it messes up the way the problem works. So if you get a even index radical equal to a negative number, stop there and put no solution. Alright, so let me work through some of these and show you. So the first one, I got a square root, 4x minus 5 equals 1. Now that 4x minus 5 is the radicand under the radical, which means that this radical is by itself as I needed in step 1. So I'm going to go to step 2 and raise each side to the exponent that matches the index of my radical. So remember, there's no number there, so it's like a 2. So I'm going to square both sides. So notice how I'm using these parentheses when I square everything. Now the left side, that exponent is going to cancel that radical, giving me a 4x minus 5. On the right side, 1 squared, that's 1 times 1, which is 1. Alright, the radical's gone, so now we're going to solve this. So we need to get the 4x by itself, so we're going to add 5 to both sides. So 4x will now equal 1 plus 5 is 6. And then divide by 4. That's going to cancel, giving me 1x. Now, 6 won't divide by 4, but remember, we can simplify that 6 divided by 4. So let's see, 6 divided by 4 is going to give me a decimal. But remember, hit math and enter twice, and you get 3/2. So all we did on that was divide the top and bottom by 2 to get a 3/2. Alright, y'all, number 2 here. Square root of 5x plus 2 equals 11. Alright, so on that one, I need to get this radical by itself. So since this plus 2 is not under the radical, I need to move it to the other side by subtracting 2. Alright, so that's going to give me a square root of 5x equals 11 minus 2 is 9. Now I got the radical by itself, so I'm going to raise each side to the exponent that matches the index of that radical. No number there, so that's a 2. So we're going to square both sides. Alright, so the exponent is going to cancel the radical, giving me my 5x. That's going to equal 9 squared, which is 9 times 9, which is 81. And then solve that by dividing by the 5. So let's see, that's going to give me my 1x like I needed. Let's see if anything can happen to that 81 divided by 5. Remember, that's going to give me a decimal, so I hit math and enter twice to get it back to a fraction. And it gives me 81 over 5, which means that the fraction does not simplify. Alright, y'all, number 3. Square root of y plus 4 minus 2 equals 6. Alright, so once again we need to get this radical by itself. So since they're subtracting 2, we're going to add 2 to both sides. So that's going to bring down my square root of y plus 4. That's going to equal 6 plus 2 is 8. Now, the radical is by itself, so I'm going to raise each side to the exponent that matches that index, which is 2. So that's going to equal my 8 raised to the second power. Alright, the exponent cancels the radical, giving me a y plus 4. On the right side, 8 squared, 8 times 8 is 64. And then y'all remember my last step on this one is just subtract 4 from both sides, and my y will be by itself equal to 64 minus 4 is 60. Alright, moving on to number 4. Now remember, you could be checking those by putting these numbers back into those equations and seeing if those are true statements. Alright, this is the square root of 3y plus 8 equals 5. So this one, the radical is by itself, so I'm going to start out by squaring both sides, because that's the number in that radical, which that's going to cancel the radical, giving me my 3y plus 8. That's going to equal 5 squared, which is 25. Alright, so let's finish it out by solving for the y. So let's subtract 8. That's going to give me 3y equals 25 minus 8 is 17. And then divide by the 3. So that cancels, giving me a 1y. Now, if you put 17 divided by 3 in the calculator, it will give you back a 17 over 3, which means it does not simplify. Alright, number 5 is a cube root of x equal to a negative 8. Now remember, this one don't apply to my rule because that 3 is not an even number. So an odd index can equal a negative number. So since the radical is by itself, we're going to raise each side to the exponent 3 because that's what the index is. And I want to raise that negative 8 to the third power. So the exponent cancels the radical, giving me my x. And then negative 8 to the third power would be negative 8. Arrow up to get that 3 in there. And negative 8 to the third power is negative 512. Alright, moving on to number 6. 6 is a square root of x plus 3 equals negative 8. Alright, so the radical is by itself on one side equal to a negative number, but this time that has the index of 2, which means it's an even index, and we said if it's an even index, then the radical could not equal a negative number. So this one we won't even work because we know it's a no solution. Remember, an even index cannot equal a negative number, but an odd index can equal a negative number. Alright, 7 is a cube root. X plus 5 equals 2. Alright, y'all, so this radical is by itself already, so I'm going to raise each side to the third power because that matches the index of my radical. So that exponent cancels that radical, giving me an x plus 5. That's going to equal 2 to the third power. Well, 2 times 2 is 4, times 2 is 8. Alright, last step, get the x by itself, so subtract 5. And it looks like x equals 8 minus 5 is 3. Alright, number 8 is a fourth root of y minus 1 equals 2. Alright, so the radical is by itself, so we come in and we're going to raise each side to the fourth power. Alright, so once again, the exponent cancels the radical. You get y minus 1. 2 to the fourth power is 2 times 2 is 4, times 2 is 8, times 2 is 16. Alright, get the y by itself by adding 1 to both sides. And I get y equals 17. Alright, y'all, looks like a couple more. So this one is a cube root of 2x plus 7 equals, oh, that's plus 1. So plus 1 equals 9. Alright, so we need to get the radical by itself because I got that plus 1 there. So we need to subtract 1 from both sides so that I get my cube root of 2x plus 7 equals 2. 9 minus 1 is 8. Remember, the first thing you got to do is get that radical by itself. Now the radical is by itself. I can raise each side to the third power. Alright, so the exponent cancels the radical. We get 2x plus 7. That's going to equal 8 to the third power. Y'all, 8 times 8 times 8 is going to give us 512. Now, let's finish this by subtracting 7 from both sides. So that's going to bring down my 2x. 512 minus 7 is 505. And then finally, divide by 2. And let's see, x equals, because that's going to give me my 1x. Let's see, 505 divided by 2. This shouldn't simplify because 505 is not an even number. So watch, when I hit math and turn it back into a fraction, I'm going to get 505 over 2 as my final answer. Alright, y'all, looks like we got time for another one here. So we're going to go to number 10 now. Alright, number 10, I got a radical on one side with 8y plus 2. That's equal to a radical on the other side of a 7y plus 4. These used to be my favorite because since I got a radical on both sides, I'm going to start out by raising each side to the exponent that matches these radicals. And guess what? Since they're both square roots, I'm going to square both sides. Because this exponent is going to cancel this radical, giving me an 8y plus 2. This exponent is going to cancel this radical, giving me a 7y plus 4. Alright, so all I'm going to do now is get the y's on one side, numbers to the other. So let's subtract 7y. So y'all look, 8 minus 7 gives me 1y plus 2 is going to equal that 4. And then subtract 2 from both sides. And I get y equals a positive 2. Alright, y'all, that is the last one. So good luck and see y'all later.